Hello, everyone. Welcome to episode 34 of the Day Zero podcast. I'm Spectre. With me is Z. We're going to be doing something a little bit different today. We're going to be doing our shoutouts at the beginning of the podcast rather than the end. So our first shoutout is we did a video last week. For those of you that might have missed it, we did a video of some stuff you can do while in self-isolation to learn exploit development and stuff like that. And we titled it Learn Exploit Development While Not Dying. So we have the video up for that on stream. And we also
Yeah,
have a
that
blog
went up
post
on
that accompanies
Monday,
it.
but so for those of you in the Discord, you will have already been alerted to it, but figured we'll mention it here too, if you're still isolating, which I imagine for a lot of you will be.
Probably for a while.
Yeah, we'll see how long it keeps going.
Yeah.
There's just a few resources that we both kind of recommend as, for the most part, they're generally oriented towards beginners, at least beginners to the exploit development. So some of them definitely do have some prerequisites, like knowing a bit of assembly or C or things like that. We mention it in here, but we go into a full discussion on all of these as to why we recommend them, and what they're good for and stuff. So I think we talked for like 40 minutes about it.
A lot longer than we thought we would.
Yeah.
Yeah.
So I think there's definitely some value in that discussion, though. If you're just looking for something to do, give it a listen.
Yeah, just wanted to give it a quick plug. But there was also something we missed in that episode that we also wanted to bring up.
Yeah, well,
and that's exploit education.
Missed their update a bit. Yeah, so with exploit exercises, it's something we both kind of looked at, something we recommend. They have several servers that you can self-host and then exploit, and they kind of walk you through different techniques. Yeah. I'm a huge fan of them. It turns out, so we had thought that exploit exercises just simply went down. Turns out they've just rebranded to exploit education. So just wanted to kind of call that out basically and mention that, they've actually kept going basically. And one of the things that's interesting is Protostar is kind of my usual recommendation as like, once you've got the basics of exploit development in place, so once you kind of know how to do some basic Stack Overflow, just not mitigations or anything, but just learning your basics, I generally would recommend Protostar as one of the good servers just to work through, because it would walk you through kind of the basic attacks and just introduce you to everything. So they've actually updated that server in particular. So they still have Nebula and Fusion, which are from the original exploit exercises, but now we have Phoenix instead of Protostar, which is again very similar. One of the big changes though is that you've got under downloads, you're able to download this with ARM64, MIPS, and PowerPC. So basically, you've got
awesome.
You've got more architectures to do the same sort of attack on, to have that same practice, but play around with it with different architectures. I haven't had a chance to really look into if any of the challenges have changed in terms of like from Protostar to Phoenix, but it looks like it's all fairly similar. I'm going to assume that the big change is that they provide images going on to other architectures.
By the way, something I just noticed, is i486 a typo? Did they mean i386? I don't know. I just noticed that on the page. But it's really cool because when you're talking about exploits, the architecture does matter quite a bit. If you're exploiting like something you use ROP for, exploiting that is going to be very different in an ARM environment compared to an Intel like x86 environment. So
yeah, and just
getting
for
all those
anybody
different
listening,
images are really cool.
The main reason for that being that ARM has a static size for their instructions, whereas with x86 and x86-64, you've got variable size instructions, which means that you can kind of jump into the middle of an instruction. It'll decode differently, giving you more gadgets. So when you move on to ARM, you're kind of dealing with less gadgets, a little bit less room to work with.
Yeah, it's harder to do. I find it interesting they included MIPS and PPC as well, because there's not many real world scenarios that are using MIPS and PPC anymore. Those are kind of dead, but it lends kind of to that fun aspect. If you want to go exploit a PS2 or something, you can download the MIPS image to learn about that. But yeah, it looks really cool. The site Yeah, like they seem to like underlines a lot for their menu. That's something I noticed just looking at it. But yeah, it looks nice. Exploit extras, like you said, I've done it before. It's a cool. They've got some really cool challenges.
So I
it's
will
probably worth
mention
checking out.
that does look like, I'm just clicking through the challenges here. I don't remember what the original challenges were.
They do look
Yeah,
different.
okay, so they have changed. I
Yeah.
see here because they're using like locals.changeme, which I'm almost certain in the original they wouldn't have done. But that just has to do with the fact that now the buffers or the ordering isn't guaranteed when you compile. So they're using that structure to get that guaranteed order.
Yeah.
So yeah, they basically updated it to work more with modern systems, which is exactly kind of what you'd want.
Another thing that's worth noting that we kind of skipped over is that they are providing the challenges not only on different architectures but also on different 32-bit versus 64-bit. And when you're talking about buffer overflows with things like stir copy, that does make quite a difference, because in 64-bit you're going to have addresses that have null bytes in them, which is going to potentially interfere with your exploit. So that's another thing that's worth noting, is that they have 64-bit challenges, which I don't think Protostar had.
No,
So,
Protostar was
that
definitely
gets
just
more real
32
world.
before.
Yeah, so that's a big improvement, just that alone. So yeah, overall it seems like it's a lot better. So definitely worth checking out. I did want to shout out from chat. Oil saying Hex 539 challenge site is a good time. Thank you. That's another thing that we plugged in the Learn Exploit Development While Not Dying video. It's our own little challenge site that we run for anybody who's interested in that. I said I was going to add a challenge to it, but I didn't, because I was a liar. But we're going to try to add more challenges to it, because there hasn't been a new challenge in a little while. So we're going to try to get back to actively developing that. But anybody who wants to check that out, you absolutely can. I also want to take the opportunity to mention that you guys can absolutely ask questions. This is probably going to be a shorter episode. We don't have as many topics as usual, and I think that's largely due to some of the world events that are happening right now. So feel free to ask questions and stuff like that in the chat as well.
Yeah, distract
we'll
us.
definitely answer them. Distract us, yeah. Feel free to interrupt us. So with that said, we'll jump right into news. So first we have Pwn2Own. So we've been talking about Pwn2Own a little bit over the last few podcasts. First, they were going to allow remote participation. Then they made it participation only on the last podcast. And then it happened last week. So we're going to talk about some of the results. It did seem like less teams competed in this one than I've seen before. And I feel like that
there were 6 teams.
Participation could be a factor.
6 teams this time, and yeah, I mean, so I want to comment, maybe you'll know something about this, but fluoroacetate, and then there's also fluorescence.
I think,
and it's the same guy. It's Rich. Well, no, it's only Richard Zhu. I apologize if I'm pronouncing that wrong, but only he's part of fluorescence, which is why it felt a little bit weird. Because if you actually check out what the results were, which is on the day 2,
they're listed differently.
Yeah, they're listed separately, and I'm wondering if it was just so it didn't seem like they completely destroyed the competition. Because if you combine them, and it is the same person on both teams, then they'd be up at 13 points, and second place only at 7.
I found that interesting as well. I was just thinking maybe it was, bugs that Richard Zhu had that he didn't want to share the payout for with the other member of fluoroacetate. I don't know.
Yeah,
it's a little bit.
It definitely could be. I mean, it was, so they both, or his bug, it was just one for $40,000 and 4 points. It was a UAF on Windows 10 to escalate the system.
Oh, okay.
And then it was a different UAF that fluoroacetate put out to escalate the system for the same prize amount. So, I mean, it could be. It's just, I thought it was funny to see that.
Yeah.
That's
surprising nobody.
Won
again.
Yeah, fluoroacetate won 9 points. One of the things that I won't necessarily say completely surprised me, but they do mention here the very first exploit, I believe. It was Apple Safari with a Mac OS kernel escalation privilege. And they explicitly mention chain together 6 unique bugs.
Yeah.
And I'm trying to figure out what those 6 bugs were. So I can imagine, user land and kernel land ASLR. So like some memory read or something like that being 2. They mentioned some JIT vulnerability. Okay, so there's one more. and then the talk to or the race condition to escape the sandbox, pop a root shell. So there's 4 exploits. What were the other 2?
It could have been something like a sandbox escape, just because when you're talking about Apple, their sandboxing is generally pretty strong.
Okay,
so it could have been another.
When it comes to Apple, are you
that.
generally getting sandbox escapes that don't end up getting you to root? So sandbox escape that isn't also a kernel privilege escalation?
I think that is more common in Apple stuff, just because of how strong their sandboxing is. So that might.
Yeah, so I'm not too familiar on that point. So, but that would give you like 5.
Yeah, and then you could also count, they say they disabled system integrity protection on the device. That could also be another bug.
Well, I don't know. They say that was done just to demonstrate that they had kernel level access, so I'm not sure that would be counted as a separate bug.
It depends on if they consider it a higher privilege than the kernel. I don't know if they do. Because Apple does since have it's to demonstrate, they consider higher privilege than kernel.
They say it's just to demonstrate that they achieved kernel level by doing that, so it sounds to me like it's at the same level. Oh no, I mean, they just haven't given us the information to really know what they were, so I was kind of speculating on that. I mean, 6 bugs is definitely a lot for any exploit chain.
Yeah, it's unfortunate. Like with Pwn2Own, you're never going to get those like juicy details. It kind of sucks, but one thing I did notice though is it does seem like they are giving more details than I've seen in the past. They have like little short videos of them running the exploit attempts. They do have censoring, they have black boxes or blurred boxes or whatever over the sensitive information in the videos, but they have some screenshots and videos and stuff that go along with it, and that seemed pretty cool. I don't think they've ever really done that before.
No, and I think that's probably unique kind of
taking advantage of the remote participation.
Yeah, taking advantage of that remote aspect, I think, is a big reason for that.
Yeah. So at the top of the blog post for day 1 and day 2, they have a short, like 5-minute video that's like a montage of all the attempts on that day. So, I thought that was pretty interesting. I didn't watch through all of them. It's mostly just like reactions and stuff of people putting their hands in the air when their exploit works. But, that might be interesting to some people. Throughout the entire event, there was only one failure. That being the Synactive team, they tried targeting VMware with a VM escape. They couldn't get their exploit working, but ZDI did validate the bug and purchased it. So
they still VMware Workstation.
Yeah. So there were a lot of different targets in it. You had Safari, like you mentioned, with the kernel escape. There was a Windows bug that you mentioned as well.
So two Windows. Stuff. So going basically top to bottom there, we have the Safari to macOS kernel exploit or elevation that we were just talking about, the 6 bugs. Then we've got we've got 2 Windows 10 use after freeze leading to system escalation. Ubuntu desktop. It's improper input validation in kernel, $30,000 for 3 points. That was by Red Rocket CTF. Star Labs had Oracle VirtualBox, out of bounds read for an info leak, and uninitialized variable for code execution in the hypervisor. Fluoroacetate had an Adobe Reader and local privilege escalation, so another Windows kernel bug, and one in Acrobat, both use after freeze. We just mentioned the VMware Workstation, and then ZDI kind of showed off a VirtualBox out of bounds read for info leak and use after free for code execution.
Yeah, that was kind of a bonus thing.
Yeah, they have a video of it, kind of at the end of the day 2 post.
Yeah. So it seems that this event went pretty well. It seemed like it was a bit shaky as to what was going to happen. It seemed like it worked out. The calls looked like they all went well, and I think there were multiple attempts allowed, because just judging by some of the stuff I saw, I think in the little bit of the video I saw, they did allow people to resubmit. I don't want to say for sure, but I think that happened. But this kind of makes me wonder if we will see more support for remote participation in the future, because this was kind of a trial run and it seems like it went over well. So I do wonder if, when all this shit happening in the world blows over, maybe this will become something that continues to go forward in future Pwn2Owns.
It seems like there's the possibility now that it's been tried, but I assume there's also going to be a pretty strong push not to have it become the new normal. Just for whatever reasons that ZDI's kind of decided to not allow it in the past. Because I mean, it's always been something that could be done in the past, so that hasn't changed. Like their reasoning still has to be there, and I mean, part of it is also just it is run at an event. They're trying to encourage people to also come to that event.
That's what I was gonna say. I think CanSec West would probably not want the remote participation aspect, but you know, I always thought the like only on site allowed was kind of silly, just because it would really suck if you flew down to the event specifically for your exploit for Pwn2Own and then it didn't work, or the vendor patched it the night before, and then not only are you screwed out of your exploit money, but you also spent money for the travel there, and then you get nothing out of it. It's gotta kind of suck, but you know,
yeah, that's the risk of it.
Yeah, that's good. Adds risk to the contest, but yeah, I don't know. It'll be interesting to see if maybe in the future, you know, because this went over so well, if they do allow remote participation. But yeah, seems like it worked out well. That video on the VM escape and VirtualBox, I think, is pretty cool. They mentioned, yeah, it was an out of bounds read for the info leak and a UAF for the code exec. So that might be interesting for people who are interested in VM stuff. So, but yeah, overall, looks like it went well. Things that might not go well, though. We have a DEF CON CTF worry with the QUALS. They've actually delayed it due to COVID-19. You know, that's brought many cancellations and changes to events. And the next big conferences happening are Black Hat and DEF CON. And DEF CON has a, you know, fairly big CTF
depending on how you're going to call it. I mean, Recon, I don't know if they've canceled, but Recon's usually during June.
I think it's almost guaranteed they're canceled. I think they're a little bit too early. DEF CON's in that window where it might be late enough that it might escape it, but I think Recon's
I mean,
done.
DEF CON officially will make the decision on June 1st.
Yeah.
Unless they do decide earlier, but the last thing that I've seen said was June 1st. That said, this is Order of the Overflow, the guys that organize the main CTF and obviously the qualifier, pushing it off to May 16th.
Yep. The obvious question that I asked when I saw this post was, the qualifiers are online, so why the delay? And they said the reason for the delay is they wanted to give people the ability to deal with all the stuff going on in their lives right now without worrying about the CTF.
Yeah, which makes sense. Cool. I mean, it is online, but obviously there is a lot of changes that are going on right now. So, I mean, I'm certainly not going to complain about them giving people more time to prepare.
It's reasonable, I think.
Yeah.
I mean, there's, you know, CTF players are probably dealing with stuff right now where they don't want to have to put all of their effort and focus into a CTF. They want to deal with real life stuff. So I think that's pretty cool of them to give that, you know, extension. It's not too surprising, especially considering we don't even know if DEF CON's going to be happening this year. Like you said, they're going to, you know, keep a lookout on it and make a judgment on June 1st to see if it's going to happen or not. But as far as I know, even the casinos in Vegas are still shut down. So if they stay shut down, DEF CON's absolutely not going to be happening if they're still shut down in August. But yeah, for once the DEF CON is canceled, we might have merit.
That too, but maybe we'll get an online main game.
Yeah, that's possible. I think that would probably be more favorable to canceling it outright, right? But
I mean, there would definitely be some significant challenges to doing it online.
Part of the problem is not being able to limit team size. Online you can have like hundreds of people, whereas on site you can only have a few people. You can have people backing you up, I guess, but
so that's actually a common thing. I mean, I don't know. So with, I want to say Legit BS kind of started the trend where they tried to make the challenges more difficult so that you wouldn't get as much of a benefit by having a ton of people on your team. There was one year where a fairly large team won, and I want to say that was organized just before Legit BS took over, who were the previous organizers before Order of the Overflow. And I mean, so yes, it's definitely possible when you're there and in person. There's the 8-person limit to the table, but then you have a runner who will run things back to a team that's still playing, either in a hotel room. Well, generally speaking, yeah, in a hotel room is where they'll be. So you'll just have one person that's basically your dedicated runner, ushering things back and forth.
Imagine being that guy. That's got to be like a really weird job to have.
Well, I mean, when it comes to the main game, though, everybody's kind of got their job. Like everybody's
Yeah.
got different positions that are being run, and you can split off some jobs to just being, looking at the software that needs to be exploited. Like that is something that can be done without being at the table. Whereas, the network guy or something who's doing more of the defensive or replaying attacks back out, catching and releasing the exploits, you can't really do that from the back. So it definitely does happen, but I do believe Order of the Overflow and LegitBS are both making a significant attempt to kind of curb that by having more difficult challenges that kind of you gain less of a benefit by having a bunch of people working on them.
I must be wrong just by the way you were, stating that with LegitBS, but I thought LegitBS ran attack defense style CTF instead of Jeopardy style. Am I thinking of something else?
No, that LegitBS did attack and defend. So does Order of the Overflow. So what are you mistaken there?
Wait, the finals last year were attack and defense? Are you sure? I thought they were, because I remember visiting the main.
Well, yeah,
CTF,
what was it, Ropship?
Oh yeah, that's right.
That's attack and defend. Yeah. I mean, that's a little bit more literally on the attack and defend too, but no, it's still, as far as I'm aware, last year was still attack and defend. Like there are specific challenges that are set out, but it's not like point styles. You're capturing the flags of the other teams during the main game.
Oh, okay. So those, styles of CTF are also harder to win with like a big team behind you too, just because of the nature of it. So I don't know why I was confused there for a second. The way you were talking about it, I thought it was Jeopardy, but I knew in the back of my mind that past DEF CON CTFs have been attack and defense. So
yeah, perhaps you're kind of leaning towards that just because of mentioning kind of like people taking and working on the specific binaries alone kind of comes off as like a Jeopardy style thing.
Yeah, that's what I was thinking of.
And it definitely does, but at the same time, they're still just challenge binaries. Like even after the game shuts down for the night, you're still trying to write exploits that are going to work on everything. So when you start up the next morning, you start firing off those exploits first thing. And so
there's no sleep allowed
right away. Yeah,
DEF CON CTF. Yeah, so it can get pretty crazy. But we can move on from DEF CON CTF. Our next topic is a little bit weird. It's not a classic news topic we usually cover, but it's actually a job posting by Apple.
Yes, and we're not recruiting for Apple.
Page. Yeah, we're not Apple recruiters. We're not shills for Apple, don't worry. But it's basically one sentence in the summary for the software engineer hiring position they have that kind of jumped out and will be the focus of what we talk about. And that's basically following a very successful run, our foray into Rust, we are migrating an established code base from C to Rust. That's really interesting.
And building new functionality primarily in Rust. So obviously they're looking for somebody with Rust and or C experience, low-level networking, Unix-type operating systems. Essentially, I mean, it sounds like Apple is looking to move to Rust in a very significant way, and they've done this fairly silently.
They're embracing the way of the Rustations. I personally didn't think Rust was mature enough to be used at the enterprise level yet, but it seems...
so Rust did hit... I mean, it's been a few years now, but Rust did hit 1.0, so they've stabilized the API, and that was the big thing with Rust before. Before 1.0, a ton of changes have happened. I know the first time I looked into Rust, I was just looking at 1.2, just do some open source work with Mozilla. I just wanted to kind of get involved there. And, at that time, Rust had like 5 or 6 different pointer types. And that's obviously been knocked down. But there's just been some very significant changes over that. Since they've stabilized it, there has been kind of just more and more adoption of Rust. Generally speaking, the things that are being done in Rust are kind of back end, not prominent things. Like nobody really knows what things are written in. So unless they advertise they're looking for Rust, you don't really know that Rust is being used.
Yeah. I mean, my thoughts on Rust specifically is when I've looked into it, it looks very painful to develop for. And then we've also talked about it before. We've talked about like the compile times can be insanely long because of all the compile time checks and stuff like that, which when you're talking about monolithic code bases like kernels or browsers or something like that can be a significant factor. I will say though, Apple, in terms of language usage, doesn't always set the standard on what's used. So even if they use Rust, that doesn't mean that like everyone else will start using it too. For
No,
example,
but it's
like
nice to
Apple
see.
used Objective-C, but it's not really used by other entities. You think it's nice to see? You like the Rust adoption? You're all aboard the Rust train?
Well, so I've already said, like, I do think that's going to be another language besides Rust that takes these ideas that Rust is kind of champion, the borrow checker namely, but just in general, it's going to take those ideas and maybe smoothen the edges out, make it a little bit easier to work with. I've recently heard actually that D now has a borrow checker coming. It possibly already has it. I've never really worked with D. But I mean, just once we start seeing that, like, I think I like the ideas Rust is pushing, and I mean, if they're going to develop in Rust, great. Obviously, Mozilla is behind it, so Rust isn't going anywhere anytime soon, unless Mozilla does.
And I think Microsoft's looking at adopting it too. I feel like we talked about that recently.
Yeah, so while, I mean, Rust has its rough edges, I'm definitely, like, I'd like to see it being adopted because it is a more secure option. Compared to just writing in C. I mean, yes, you can do C correctly, but nobody seems to do C correctly.
Because you're not forced to. Rust kind of forces you to. It's a more aggressive language at pushing the more secure stuff.
Yeah, and that's one thing I do like, where I'd even say Rust is an interesting language to learn just as a learning experience, because it kind of forces you to learn something good patterns when it comes to managing memory, when it comes to managing pointers. And you can take those habits out to whatever other language you want that also lets you deal with memory at that level. It builds up some good habits. Yeah.
I will say, just because you write your stuff in Rust, I want to stipulate that doesn't mean that it's unhackable trademark. There's still issues you can get from Rust. It's just...
Yeah, there are things it doesn't defend against, but it defends against some of the big issues that you do run into.
Yeah, for sure. So... Firefox is prototyping a Rust-based browser engine, like you were saying, or Mozilla is. And like I said, Microsoft's seeing some adoption. So it looks like we're seeing Rust kind of take off, and maybe it'll be like the mainstream language within the next few years at the enterprise level.
Did I mishear you? Did he say Microsoft was doing a Rust-based?
I don't have any, anything to point to, but I feel like we have looked at something rather recently.
Well, there was Project Verona.
Maybe that's what I'm thinking of, because I know Microsoft has been at least looking at it. I don't know if they're
so Project Verona was the research language from Microsoft.
Yeah, and they were looking to...
Well, they borrowed some ideas from Rust in that.
But they also said they were looking to kind of experiment with some features that could be ported into Rust if they worked out as well.
Okay, so, I don't recall that specifically, but I have no reason not to believe you.
Oh, I'm just a liar. No, it's okay. No, but I do remember they were saying they were trying to build up the stuff they were working on so that it could be ported into other languages like Rust if it was worthwhile and people didn't want to use their language. Yeah. So yeah, maybe we'll see Rust become like the new Java at the enterprise level, perhaps.
I doubt that.
You doubt that?
Okay. I doubt we're going to see Rust at least this year. In the immediate future, becoming an enterprise language. It's just got too many rough edges. I could see it being used like Apple's looking for here, where it's kind of moving some C to Rust, used in places where you're already seeing C, where you're seeing kind of those more insecure uses of C, or at least some more risky uses of C, especially like network services, being done and being moved to Rust, but... companies that are using Java probably aren't moving to Rust. They're very different.
I didn't mean Java as in like Rust would replace Java. I just meant like how big Java is or how much it's used. I was just kind of trying to make that equivalency. That probably was like a bad equivalency I was trying to make.
I mean, yes, 2020, the year of Rust.
Yeah, the year of the Linux desktop too. No, the last thing I'll say about Rust is... one thing I've heard that people are saying might be a good application of it is when you're talking about kernel, there's been like a push to put Rust into the kernel. I'm not a big fan of it, but I'll talk about it just because the common thing I've seen that is generally agreed upon is what might be a good idea is writing the kernel core in C, but then doing kernel drivers and stuff like that in Rust, which, so basically taking the parts of the attack surface that are more commonly hit or more commonly have issues and have like less of a potential performance cost, and converting those into Rust.
Yeah, and that's
building a kernel driver is going to be a lot easier than building kernel core.
Yeah, and that's a really important point. Like Rust, yes, they have a ton of the zero cost abstractions, which I would love to see getting adopted out into other languages too. But the other thing, Rust does, like some of it does add performance overhead. It's not, generally speaking, I mean, yes, there are some optimizations that could probably be applied in Rust versus C, but generally speaking, C without all the extra checks is going to be faster than Rust, which automatically does some.
Yeah, it is still pretty fast though. So.
Oh yeah, no, like performance-wise, it's still good, but when we're talking about the kernel, you're really trying to eke out quite a bit.
Oh yeah, for sure. So basically what we're saying is we're pushing for Rust. We're going to make sure that 2020 is the year of the Linux desktop and the Rust programming language. But with that said, we'll move on to exploits. So our first exploit, it's been a while since we've talked about car hacking. So naturally our first exploit is going to cover vulnerability that affects cars, more specifically Tesla Model 3. It's a denial of service. It's a very trivial exploit. It's just a web page that runs a loop that pushes a bunch of characters to a string and pushes it into the history state. So all it does is it hangs and crashes the browser. And because of the way that the Tesla system works, that basically ends up disabling the speedometer, notifications from the auto driving, infotainment, all that stuff is disabled. And one quick tip, if you check out this article, they have a link, nullz script Tesla crash. Don't click that link. They even have a warning there, but I didn't read that and I just clicked the link. I did end up crashing my browser and hanging my system for a little while, but yeah, just don't check that link. They do have a GitHub though. If you search for the CVE, or you can do a view source, you can see what the issue basically is.
Yeah, I was just going to say, is it safe for me to do a view source on it?
It should be safe.
Let's find out. Either the browser's going to crash and we'll have some entertainment. No, it worked. Okay.
Testing in production. Okay, there we go.
Although I hadn't looked at this before, so yeah, it's definitely been.
If you find it on GitHub, it's a lot nicer. Yeah.
Not totally minified though, which is weird. Usually, you're going to just see everything replaced.
Yeah.
Either way, I mean, it's basically they mention it as just being a JIT bug resulting in the crash. I find it odd that everything kind of went down. Like, what is Tesla running an Electron app? Like, is that what this is? Crash Chrome, crash everything.
I don't know how like the browser is so interconnected with all the other subsystems.
So
but
that's why,
really
like,
dumb.
if it were something like an Electron app, if all of this were web UI components and the browser was just another kind of little component in that app, just the web view.
It wouldn't surprise me, honestly. Like,
it wouldn't surprise me either, but I mean that separation should really be there.
Oh, for sure. Like, you don't want a malicious web page disabling your speedometer when you're driving a car.
I mean, who needs that? Does the Tesla, do they have a mechanical speedometer also? You know?
I'm not sure.
I mean, I've never driven one. I've never been in one, so I can't say, but...
I'm a bit too peasant to drive a Tesla. But, yeah, I'm not sure. We might have to look that up.
Yeah, I'm actually just pulling it up here to see. Doesn't look like there's anything...
It looks like it's all digital.
Yeah, which, I mean, kind of fits with Tesla.
That just means you're screwed. That's oh man, I don't agree with that at all. I think that's really dumb. But I think that's the point of the article too, right? Is the vulnerability itself really isn't that interesting. You probably don't even need to look at it, but it highlights that we shouldn't be using browsers for everything, and they should be isolated, especially in things like cars from other systems. Like,
I mean, to be fair,
notifications,
it is just the UI. So presumably you're not like the CAN bus isn't affected by this crashing or something. Like presumably there's at least some separation there.
No, but you can pull over and reboot the system or whatever.
You can't always do that though. I mean, you're driving down an interstate or whatever.
No, that's true. But it's not like you were saying. It's not going to compromise your control of the car. But it is pretty serious. Like, not being able to see autopilot notifications in the speedometer is quite a hindrance when you're driving. So it's a bit worrisome. Hopefully, those are separated in the future. I don't know if I hold out too much hope just off of what we've seen in the past. But
yeah, I don't know, because
maybe
it seems like it's an architectural issue. If it's being able to bring down everything, that seems like they've architected this in such a way that it'll bring down everything, that everything's all interconnected there in terms of the UI.
It's actually so easy to DOS a browser. Like, you can just write any old JavaScript, and it's not even really considered a vulnerability. You can just write something that loops like 1 billion times and does an intensive operation and, hang the browser or slow it down. So, like you said, it's an architectural issue, and that's why the vulnerability isn't really that interesting. There's like hundreds or thousands of other ways you could hit this and do the exact same thing. So, yeah, it's a bit worrisome. I'd say Tesla really needs to redesign how that works, because that's really stupid. That's that is actually like a lot of the car hacking stuff we cover is kind of theoretical and won't really happen in practice, but I think this is one thing where I could absolutely see people putting up web pages and trying to get, like, checking the user agent maybe of the browser, seeing if it's a Tesla or a system that Tesla uses, and then does something stupid like this. Like, it seems like an attack that could happen in the real world. So that's what kind of worries me about it. Yeah. So not too much to talk about there, but, hopefully Tesla reworks that. But up next, we have another thing that we've talked about before, and that's a security review on Voatz from Trail of Bits. And if Voatz sounds familiar, that's because we've talked about it. I meant to go back and get the exact episode number. Okay,
episode 29. So MIT put out a research paper where they did an analysis of Voatz, which is a voting application used. It's apparently been used for some US, for voting. So MIT think one of our big issues kind of on that was just coming back to the fact that they only looked at client-side issues. At no point did they actually hit the Voatz server or do anything that might get rejected by the Voatz server. Like, they had no way to actually validate that. And of course
they were completely black box.
Yeah, completely black box and not even hitting the actual server. They only focused on the client-side application, issues in the client-side application. So they mocked their own server up for it, which we talked about this during episode 29. Part of the reason for that is because Voatz had actually, taken legal action against some researchers in the past. Mm-hmm. So just don't hit them if they're not going to cooperate. And there's some back and forth about whether or not Voatz is cooperating. They have a HackerOne bug bounty. Seemed to be a little bit contradictory in a few points, but we talked about that in episode 29. That said, Trail of Bits here does actually review the MIT report also, and first of all, I'll say with last time I was able to kind of try and defend Voatz a little bit by mentioning, they have, we don't know what the server does in response to any of this. If something's sent along, if they're using something that the researchers just didn't notice. In this case, we're just saying Voatz has a ton of issues. With this assessment, they had source access.
It's completely white box. Yeah.
White box, yeah, but they didn't have access to actually hit a live system until the last day of the assessment, I believe. I'm not sure if that's mentioned in this report or if that was mentioned elsewhere, but that is one thing. That is one thing that came up. And I don't think we're going to take the time to go through absolutely every issue.
There were 48 issues.
So I don't know. I took note of a few that were interesting, or at least worth mentioning to me. So actually, in terms of length, this is 122 pages, and there's another one that deals just with their threat modeling. And kind of higher level issues, process issues. So yeah, I guess page 40 is kind of where they start with some of the back-end findings. One of them here being the device ID is not validated against inner request device IDs. Essentially, when you're requesting the encrypted API, it would encrypt what your actual request was, and it would send along your device ID with that. But the actual request would also contain a device ID. So you can encrypt your request, and your request you have your own key, so it kind of validates the device ID by the fact that you have the right key for it. But because the inner request, it didn't actually validate that it was the same device ID, you could send you could send requests to the API as any other user. So their example case was sending the API request that would indicate that a device was compromised, that a threat was detected, and it would ban, you could ban anybody if you knew their device ID from voting. So denial of service on, your
Voter
ability
suppression,
to vote.
easy
Yes.
mode.
Yeah, I mean, you do need to know the device ID. So to be fair, and that happens in a number of these, you do need some level of knowledge. Not all of them, but a lot of these issues are still very bad signs, regardless of the fact that you do need to know something. Like an issue like that, you should be validating the device ID. Just only send it once and use it from that original bit. That way you've kind of got the validation and nobody can spoof that. Without knowing the private key associated with it, which presumably isn't going to be too easy to get. Going on, kind of the next issue here, actually, the next page, is the admin password for Amazon was hard-coded in one of their test files.
That's pretty funny, too.
So to be fair, it could just be an account named admin that isn't actually admin. They don't specify what the privileges were that this account had, but its username was admin. So that probably tells you what it is.
Well, they do say that using that, an attacker can install rootkits on Voatz servers, so it does have quite a high level of privilege.
That's what their exploit scenario is, which they don't necessarily... their exploit scenarios sometimes are being based off of some speculation. And actually, I'll be mentioning that later on about one of them. Just in terms of something they did that I like. Okay. But still, I mean, password in source file. I mean, it's when it comes to testing, I see this a ton. I mean, I remember there's one particular client I used to work with, and they were really good about not having passwords in the source. But like so many of their teams would have passwords in the tests. Usually those were just test account passwords. I mean, it was somewhat explicable, but yeah, with this one, might be a little bit worse. Again, called admin kind of sets the wrong idea.
Yeah.
Moving on, pretty much the next one again. Non-anonymous ballot receipts are encrypted with AES-CBC using hard-coded key and IV. So basically you would get, when you would vote, part of trying to have verifiable voting, which this is not, and that's a huge issue I think with Voatz, is it is not verifiable voting, end-to-end verifiable voting, which I think is essential for any voting system that's actually going to be used. So right there, I wouldn't really support using this, but they give you a QR code that basically decodes to some information about how you voted. Since it's encrypted, you can't actually validate that, but you can get it validated, I believe. Basically, the key is hard-coded, and the IV. They're both hard-coded, and they exist on the Android application, so anybody can pull it out and decrypt what somebody's vote was.
And they also copied the key and IV from a Stack Overflow answer.
That too. The particular key and IV were copied from the Stack Overflow answer. I forgot to mention that. Yeah, it's
just awesome.
Like not even making trivial changes.
Yeah. Which is like kind of a code smell. It's like if they're not doing obvious changes like that, then how many other things have also just been copied and pasted and not changed, and like, it's kind of a red flag. So I think there's a lot of red flags in this report. But
and that's so one thing worth mentioning here is this is something that they are planning to phase out and that hasn't been used since 2018. So there is that aspect of it, but it should just be removed. Dead code, just get it out of there.
Yeah.
Because part of the issue with dead code is if you leave it in the system, another developer might come around and be like, oh, I mean, this function already exists. Let's just use that, not realizing that it shouldn't be used anymore.
Yep.
Obviously, this is a little bit bigger of a feature, but that's just a general problem with dead code.
Yeah, that's why you might want to deprecate things for like 1 or 2 versions, but then you want to remove it fairly quickly so that people don't use it.
Yeah, then another issue here they had is a voter can unregister another voter's device. This one is... So you would register, you have like your voter registration process where they validate you, all of that, and you get associated with the device ID. If you were to lose your device or something, you can re-register. And obviously you can't use your device ID anymore to do a re-registration because presumably you've lost your device and the device ID won't match anymore. So you can use like a phone number, and it would send a validation email to kind of confirm like, hey, are you actually changing your device ID? The problem is, well, multiple problems here. One is that the phone number is just provided as an HTTP parameter. So anybody can go ahead and make that same request. And the other problem is it basically just has a use side channel, which you can set to false as one of the parameters. And if you set it to false, it won't send an email verification.
What?
And they do something really similar elsewhere. When you're doing the initial registration in the API, you can bypass the SMS verification in the same way using the parameters test for the SMS one.
Okay, so they are just test features that were never stripped for production, basically.
Well, no, this one, I don't know. Use side is the name of the parameter is use side channel,
which is kind of a suspicious name already.
Well, I mean, it is a side channel verification. It's a secondary channel of communication, something that's outside or out of band. So, like, it makes sense. Call it a side channel.
But it doesn't make sense to have it. That's the problem.
Well, I don't know the context in which they're using that. If, say, the email validation or verification is an opt-in feature, I'm not sure what the context is for that. But yeah, the SMS one looks like it is just a test feature that got left in.
Yeah. There were some other issues, like I think some of them overlapped with the MIT findings. One of them, they mentioned encrypted application data being able to be brute forced easily. I think we talked about that in the MIT
they talk about
as well.
Like the PBKDF2 work parameter being too low for just a 4-digit pin.
Yeah.
They actually talk kind of about all of the issues. Actually, just before I go there, I will mention one of the last issues. Well, two more issues I want to pull. One is that database root credentials were stored in GitHub. One is the fact they're running the database as root, like using the root user. That's an issue on its own. And two, the fact that it's in a nice little file, deploy/secrets.txt.
Not even inconspicuous.
Yeah, so like, that's just sitting there. And one of the things I wanted to call out, though, that I really liked about this report, and this is kind of a meta thing, but in one of their issues, they mentioned that signed voter affidavits are sent to an administrative email, and they gave it the severity undetermined, which I thought was a really nice move. They've given it the respect it needs by taking this issue. It can be a real issue. They explain what the issue is, the exploit scenario, but because they don't know how those emails are actually being used, they just make an assumption about how it's being used and say the severity is undetermined.
They have a few of those.
Yeah, this was just the one that I had taken note of. But in general, using that, I think that's just a really good move in terms of the reporting style. So I just wanted to call that out as being, a good move, a good way to do it.
Yeah. I did have a few pages I wanted to shout out just because, if you're looking at the report, obviously 122 pages is extremely, extremely long. But there were 2 pages that I wanted to kind of shout out because they had some nice summaries of the findings. So on page 10, they had some tables that had some nice summaries. And then as well on page 35, they had a summary of the findings. So on page 10 there, that's where they had lines of code, more meta stuff, not really specific to the issues. They have a vulnerability summary of how many high-level issues, how many medium-level issues. But they also have some other more meta information that I thought was kind of neat, like the lines of code and stuff like that. And then on page 35, they have all the summaries kind of listed in a table of contents. So I think if you're going to look at it, those pages are kind of maybe I had page 35. Yeah, okay, page 36. I was 1 page off. So yeah, page 36, they have like a summary of the findings, and then yeah, it's like a table of contents for them. And then you can see like undetermined, informational, some of those things that Z was shouting out earlier. So
yeah, so informational is
Yeah.
pretty common, but the undetermined one I thought was an interesting, or the undetermined ones I thought was interesting to add in. And
Yeah.
also, since we did mention the MIT report, they do actually talk about the past assessment.
Yeah, I saw them mention it in
Unfortunately,
various areas.
I didn't. Well, no, they actually have a section for it.
Oh, I didn't notice they had a fully dedicated section. I did notice them
Yeah,
shout
well,
it out in a few
there's
places,
the mention of past reports. Unfortunately, I forgot to take note of where. Yeah, the MIT report, page 98.
Oh, okay, there you go.
And they actually even mentioned, so Voatz had presented some objections to the MIT report. They had mentioned, for example, that it was at least 27 versions out of date. And Trail of Bits here. Yeah, Trail of Bits just mentions like basically nothing important changed between there.
Calling them out.
Pretty much. Objection 2 was, as we mentioned, the MIT one only dealt with the client side. They also never made the claim to have been testing the server or anything, so fine. But yeah, they kind of call out Voatz with some of that. I will mention that this section was a little bit surprising. So this is their previous technical assessment. And I recall when we were talking about... also kind of interesting, between the time of me reading this and downloading the PDF, they redacted the security vendor before the 2018 one.
That is interesting.
So that's interesting, because I definitely have that written in my notes here. But anyway, my point that I was going to get onto is that when we dealt with Voatz response, they had mentioned that they were open with some researchers, and that, you know, if you're a proper researcher, because were kind of calling out MIT for their actions a little bit, that they were more open with some of the researchers. And it seems like they basically haven't had any real assessments done. So this 2018 one by the redacted security vendor was a black box without source code audit. I believe also code review. Sorry, I'm just trying to see if things have changed, like if they've rewritten this a bit, because it looks like the quote that I had, which was application and source code review, were not in scope. It appears that only the mobile clients were in scope and the servers and cloud infrastructure were not. Okay, so they've actually clarified that. That's one of the changes that they made here. My question was, it sounded like, you know, if they're not allowed to test the application and they're not allowed to have code, what was in scope? Yeah. But yeah, okay, so it looks like they've updated that a bit, so that's good. But so that's one test, which basically was another client-side one, like the MIT one.
It looks like a lot of them were in like end of 2018.
Yeah, so I guess what I noticed here, though, they also had DHS did a 1-week assessment of Voatz servers looking for signs of compromise, so not actually testing the security. Just looking for compromise, and then it's the MIT report. So it doesn't look like they've really had very much.
Yeah.
Especially in that whole like 2019 year, where it sounds like it was actually getting used.
Yeah. One thing I do find interesting is that I really like this report. It's very thorough, and I like that it kind of calls out Voatz. But why were they allowed to have the source code and be able to review the server and the client and the cloud and everything like that and disclose this publicly? Because based on what we know about Voatz from, the context of what we're talking about, like, you would think this report would never see the light of day to the public.
Perhaps. So, I mean, I think also because of the MIT one, they're getting some pressure to have a proper assessment.
That's what I'm thinking. It must be something like that.
I'm going to correct something I just said. Apparently when I was looking at the list of them, I just missed these first two, because it's this third one that has the application and source code review were not in scope for this assessment. So I'm not sure how I must have just missed those first 2 points. So I'll recant that statement. It does look like they've at least had a little bit more than what I was seeing, but still, going back to your question, I would have to guess that there's just been that pressure to have a bit more of a transparency, to be a little bit more open, because that is definitely something that, like, the MIT report got a fair bit of attention.
Yeah,
And negative attention for them.
So. Yeah, that's my guess as well. It had to have been pressure induced because, judged by what we're seeing, they don't want this stuff known. And this is pretty damning on Vo's part, like 48 issues. Like, if your report is 122 pages like this,
well, so
that's
again,
not very,
it is worth noting a lot of the issues are difficult to exploit. They do require a good level of information. They do require knowing like private keys that are device specific, for example. They do require certain privileges, like the source code things, the information source code. That's, you need to have access to the source code, which isn't going to be trivial to get. So it's obviously a concern because, especially with elections, you've got concerns about insider threats. People get the job and they get access to that and they can modify an entire election. Not an ideal case. But when you're talking about the numbers, like, a lot of them are like that. I do think just saying 40 some issues is maybe overstating it a bit, without that context. Because it's definitely easy to get a lot of issues when you report on a lot of the smaller things too. And now they do have a ton of code smells in here. They do have high severity issues, so it's not all that. I am just kind of getting at the fact that it's worth keeping that in mind when you go with just the number.
I think it's less about the issue specifically and more just that there are so many trivial issues that are just like indicate that they haven't put much care or had security in mind when they were working on it. And
yeah, I think a lot of them show that they haven't had kind of the security in mind. I definitely would agree there.
Yeah. You're always saying that, like, you're a supporter of electronic voting, but it needs more testing and stuff before it should be used in a serious context. And I think this report shows Voatz, at least, isn't ready for production, not even close.
Well, so the other thing with Voatz is they're not verifiable. They actually have this section here on page 107 about verifiability, and it's, effectively, Voatz is not end-to-end verifiable. Ballots do not protect voter identities, as they are identified by voters' device ID. I mean, effectively, this is not the voting system I would want to see.
There's
because this is basically, you're adding electronics to it. This is essentially the worst case scenario when it comes to electronic voting. You're adding in the electronics, but you're not adding any extra level of verifiability to the entire, or any extra level of accountability and transparency to the entire voting process. It's still only the auditors that are able to actually go and, in theory, validate the entire election. So it's still hidden. It's still those kind of special people who are getting that level of access. It doesn't offer any of the extra protection, or it doesn't offer any of the protections paper ballots offer. Like seeing and knowing what your vote is right in your hand, which, to be fair, end-to-end verifiable doesn't, but you have a way of verifying that, which you don't have with the vote system, or at least not to the same degree. So that's kind of the worst case, because you compromise the vote's backend, and you can compromise the entire election. It's maybe not a single point of failure. There's the blockchain. It is difficult to modify with ballots that have already been cast, and that's actually mentioned in this report too. But this is kind of the worst case scenario in terms of, if you can compromise the host, the API host, you can compromise the entire election from that one point. That's your worst case scenario when it comes to electronic voting. Because at least with paper ballots, you kind of have to compromise like a counter, like pay somebody off who's counting the votes at like every voting station or where they're collected. So it doesn't scale very well. Whereas this is a single thing that scales very well. Compromise one place and you can own the entire election. So end-to-end verifiable voting defends against that by basically everything can be compromised, but because of the math, you can still trust that your ballot's been corrected. Anybody can, so you can trust your ballot's in there. Your ballot is the same, and your ballot decodes to what you believe it does. And anybody can run the results of the election and get the same results.
This system is basically more convenient but less secure because it's also more convenient to hit. This is kind of interesting.
Yeah, it's the worst case scenario when when you see people talking about electronic voting, this is the type of system they imagine, and this is the worst type of system to have. Well, I guess the worst type of system would be, absolutely no attempt at being immutable and things like that. So it could be worse, but generally speaking, this style of system just is not what should be used. It's just too easy to compromise, even if everything were secure here, because of the scale of being able to compromise it. So compromise it in one place and everything's kind of owned. Yeah. That's kind of one of the big problems, and this is the type of system everybody imagines. So this is just really adding fuel to the fire against electronic voting, because they don't seem to understand the benefit of electronic voting, but they use blockchain, so they get the keyword in there.
It's not only damning towards votes itself; it's damning for electronic voting everywhere. It kind of paints it with a bad brush. That being said, while this is pretty damning for votes, I will say this report quality was really well written. I think Trail of Bits deserves a bit of a
they're well known group.
Commendation for that.
I wouldn't expect anything less out of them. They're fairly well known.
I think it's still shouting out though that
for sure. Like I said, I called out some of the specifics that I liked with the undetermined, for example. It's a good report, and the threat model is also good. That's their part 2 of this.
Yeah.
That said, I'll stop ranting about
we can
verifiable voting.
We'll move on from votes, and we'll start talking about some XXE stuff. So this is more of a personal blog post, so it's not like a full professional report like the last one. But we have a guy who bypassed a web application firewall for request smuggling to exploit an external entity injection, or XXE vulnerability. And what's kind of cool about that is last week, Z, you were actually talking about this, I think, about using request smuggling to get around web application firewalls. So he talks about an XXE found in a file upload endpoint, which was parsing an embedded XML in image file formats. I think the one specifically that he hit was in a JPEG. But the XXE was only through DNS. There was no HTTP, which seems to be kind of an issue.
Well, so with the XXE, basically, he could trigger a DNS request to go out, but not any HTTP. So it's not necessarily that the XXE was in DNS, but when you try and have your remote DDT, or you would have something in there, you try and get a request to happen so you can start exfiltrating data, assuming this is blind, which it was. That would be, you try and exfiltrate your data using either DNS requests or HTTP would be the ideal case. Anyway, so what we found here, obviously, he has XXE. That's in the image format, but he can't trigger any HTTP requests, so he can't pull out a good chunk of data with it. So what he ended up finding, and this goes into some a fair bit of detail about how he kind of walked through everything and figured everything out using Burp Collaborator, things like that. But so actually, right out of chat, Security Hook mentions using FTP would be good, actually. So he actually talks about trying some other protocols. He actually even tries a Gopher, which is a fun one when it works, but it didn't work. Basically, everything outbound was being blocked except for access to any subdomain of external.company.com. Obviously, that's not the real domain, but effectively it was blocking everything. So he went and found out that on one of those subdomains, you could do an HTTP desync attack, which we've talked about both last episode and the episode prior, which is just getting your request smuggling by inducing a desync between the front and back end. So in particular, he used this desync attack in this other web application to get his request or his exfil data, to get that appended to the base of his request. And then that request would end up being kind of finished and it would add whatever was appended to the to his profile on whatever this other application was. So if you're familiar with a desync attack, basically you do the desync and then the next request that comes in will be appended to the end of your request. So you'll try and map that out so like your request has like a post body, for example. And you'll map that out with one of the variables in that post body. You'll just kind of end it with like the equal sign. And then the next request comes in like get whatever the request is. And that just gets appended in there, made to be part of your entire, whatever that variable was. So that's how you're able to kind of exfil data by having the initial request come in that does the desync. Then the attack request through the XXE comes in with all the exfil data. And he would then find all the information at the end of his profile.
Yeah, and the
example
description
down here. Yeah, so you'll see like SC get, and then you see kind of where get gets appended to his request. And he's able to pull out all the information from that. I just thought it was an interesting hack because it chains several issues. So chains an XXE with an issue in a completely separate application, but that happens to be requestable, that isn't blocked by the firewall. Which is just, I mean, it's a fun attack. You can give this a whole read to get more of the details about it, but I don't know. I love seeing those sorts of chained issues.
It's one of those multi-stage attacks that shows how much more valuable two bugs chained together can be compared to the bugs isolated by themselves. I think he even says in here a good term for it is, it's a good example of the sum being greater than the parts of the whole, right? And that's what makes it cool.
Yeah, for sure. I mean, if you reported an XXE but you can't exfil anything, it's like, okay, it's an issue. But without exfil, you're definitely limited with what you can do. You report the HTTP desync, that's also an issue, but by being able to chain them separate applications even, like I said, makes the sum of the whole is greater than the parts.
Yeah. So, it's basically teamwork for exploits, so it makes it cool. The timeline, it seems the XXE was reported on the 19th of December. The request smuggling was reported on the 20th. I don't think they have exactly when they were fixed, but they say that bounties were awarded on the 8th of January, so I'm guessing it was around that time when they were fixed, because they said the request smuggling and XXE were triaged just before that, so they were fixed in between that window. So fixed fairly fast.
Yeah, I mean, that's also over Christmas, so...
Yeah. So, it was fixed, and it's kind of a cool issue. I was a little bit, I'm not too familiar with XXEs, so I had to ask C a little bit about the document type definition stuff before the podcast. But it's definitely like an interesting read up just on, the request smuggling stuff that we talked about before and the XXE and how you can chain them.
Yeah, so, I did feel it was a little bit muddy, I guess, in terms of the flow.
All over the place.
Yeah.
Yeah,
but I mean,
I can see that.
You could get information out of this if it's of interest. You can get more details than we've covered.
Yeah. So our next exploit is in Visual Studio Code for Python, actually. And the issue is VS Code selects the project environment from the project folder. So if you install pylinter to the project, it'll use that when opening any Python files in the editor. And if you add your own malicious pylint source, you can get code execution anytime somebody opens a Python file in the editor. So I don't think it's directly referenced in this article, but I was actually able to find a POC on GitHub. Let me just bring it up on the browser really quick. So they have a GitHub page for it. So here's the POC page. So in VS Code settings.json, let me just go to that really quick. They have a bit of an example of what they mean here. So in the settings, you can set a Python path to, a folder that's basically embedded in the project. And then
so that's kind of, if you're not familiar with Python and Python's package management, virtual environments are a common way to effectively use different versions of Python to have different dependencies in your application by basically installing Python binaries into some subfolder, and all of the libraries that it needs will exist in that subfolder, and then you'll just use that Python there and all of those local libraries. So that when you're saying the Python path, you're basically saying, hey, go ahead and use this Python and all of these libraries that are built in with that.
Yeah. So it took a bit of digging to get the actual code that launches the shell, or rather the calculator, because they pop calc. I had to go digging through the commits. But I found a commit here that shows basically what happens. You just import OS and then open the calculator app. As you can see, that's for Mac OS because it's the calculator.app. But
that's
that
in
basically
the site
demonstrates they get code
packages
execution.
pylint lint.py.
Yeah. So in terms of timeline, the issue was discovered in early October, but the issue still isn't fixed, actually. Microsoft expects to ship a fix by mid-April, but it's still a 0-day. So I should mention the article authors did give a reasoning as to why they published the post, even though it's a 0-day. They say not only has it been 90 days, but the issue is also public as a GitHub issue. So it's fair for them to publish the post, and I agree with that.
Yeah,
but it is kind of interesting.
So I agree because it is. So I do agree with you. Like, I don't think it's a huge issue that they published it. It just, they also make it sound like they would have waited, or they wouldn't have waited because of the 90 days. And that, I think, is a little bit more of an issue. The idea of the 90-day timeline is you're either going to fully disclose the issue, hopefully before whoever fixes it, or sorry, hopefully after whoever fixes it, and trying to encourage them to fix it within that time period. When they've already mentioned that Microsoft has given them a rough deadline for when they plan to have that fixed, releasing it sooner isn't going to get it fixed sooner. It isn't going to get a patch out sooner.
And it's going to leave a bad taste in the mouth of Microsoft.
Yeah, so I mean, while I do agree, because the GitHub issues there, like, this is already exposed, it's nothing new, so fine, write it off. But the way they present that on the 90-day issue, I'd say is a little bit... At least be aware, because the whole point of that is encouraging a faster fix. And if your release isn't going to do that, it kind of defeats the purpose of doing that release.
Yeah.
Unless, of course, they're just not going to fix it at all, then, of course. But in this case, they had a deadline. It was a little bit outside of their 90 days. Or a lot outside, actually, because what would 90 days be from October? Okay, so that's getting closer to 5 months or 6 months. So yeah, okay, that's actually fairly long too.
Yeah, I will say, in regards to the timeline, it seems Microsoft expected the fix to ship on mid-April 2020 in January, and back then there was no knowledge of all this stuff happening right now. So I do wonder if that's going to contribute, because Microsoft is one of those companies where a lot of people are working from home now, and as much as people might want to deny it, work from home productivity does generally go down a lot. I do wonder if that will end up delaying the fix as well. Maybe not, we'll see, but that could be worth keeping in mind, that mid-April may even end up being pushed even later because of the stuff going on right now.
Yeah, it could. I mean, we'll see what happens. I believe... Yeah. I know, like, Chrome has pushed off their next update. I want to say Firefox has done the same. I don't know about Edgeum. I think Edgeum has also, actually. I think they've all done that, but I'm not confident in that. The only one I'm confident in remembering is that Chrome has definitely canceled their next release. So, like, yeah, I could definitely see Microsoft pushing off this update yet.
Yeah, but it's a fun and kind of weird issue. It's not too often you see issues that are exploiting like IDEs or code editors and stuff like that. So, it's one of those things you don't see often.
It's somewhat similar actually to what we saw last week with the Google Cloud Shell and kind of their little IDE with Python. The malicious repo was able to include
yeah, I guess.
It's similar. It's not the same. But it is another case of it trying to load packages that just, well, in that case, don't exist. In this case, you control where it tries to load it from.
Yeah, that's
so different case, but similar in theory.
Yeah, still not something you see too often, though. That being said, we'll move on to our last exploit of the episode, and that is a race condition in another CTF platform. Or maybe the same one. I don't know.
No, this one's HackerOne, so they would have allowed that to be seen. I mean, HackerOne is...
Yeah, that's true.
Yeah.
So it's a different one. It's very similar to the issues we actually covered in the last episode, and it's essentially a race where you can add yourself to a group twice.
Yeah, it's practically the same issue as the team one in the last CTF. So last week we had talked about a CTF issue where you could add multiple people to a team. So say you had a limit of 2 users. By a race condition, spamming the request, you could have multiple users join. In this case, one extra little thing happens is that so they did this, I believe, just kind of having the same user trying to join. And with this one, so again, it is that same issue with a race condition where something should only happen once. Security Hook just asked, isn't that considered a no rate limit bug? No, not necessarily.
No, I think it's more accurate to classify it as a race.
Oh yeah, definitely more accurate to classify it as a race, but no rate limit. Even if you had a rate limit of say 5 requests per second, you could still race condition it. Like the race condition still exists. A rate limit can limit the impact of it by limiting how many requests you can actually make. But the issue isn't the fact that there's no rate limit. The issue is the fact that it's not locking or it's not synchronizing between the requests, allowing, it's talk to, so time of check, time of use. So at some point it's checking how many people are in the team, or it has this person join the team, actually is probably what the check is. And then later on it's checking, and then it's using that value like, hey, there was nobody in here, they weren't already in here, so now let's add them in. But multiple threads can reach that point, and so they'll have the same account added multiple times. Which also, funnily enough, ends up resulting in denial of service, in a sense, because you can't delete this user that's in there twice. Presumably that's
in the group, basically.
Yeah, presumably that's just because you end up in a case where the query is expecting like only one result, and you get multiple results back, and the query just fails. So that's where I'd assume the issue kind of comes down to.
Yeah, it's basically the issue is you can't remove the group member, so you basically have to make an entirely new group if you want to, get rid of that member or whatever. So
okay, so dealing with chat again, Security Hook asks us, so the race condition is solved by logging the user's input. So if he added 2, it disables his ability to add another one, right? No, or at least not exactly. So the issue with race conditions is, and I'll try and keep this brief. In particular, we call this talk to for time of check, time of use. So let's imagine the code. I'm trying to think of how to describe this without being able to bring anything up to show. Let's imagine the code does something like if user. So yeah, I'm going to use the example that we saw in last week because that's maybe a little bit easier to talk through. If number of users in team is less than team limit. So it'll check that value, and then it'll step in and be like, if it's less than the team limit, add user. Simple enough code, checking the limit, adding the user. But let's say you make 100 requests at the same time, or let's say you make 5 requests at the same time, something small, so the rate limiting wouldn't hit it. You make 5 requests at one time. Of those, let's say 2 of them pass that check and add the user. And the other 3 maybe run a little bit late and they don't pass that check, so they just get tossed away. But 2 of them manage to make that check. They both get to add the user, even though at some point those values will be out of sync. Even though at one of the points you'll add the user, but because it still has passed the conditional check on another thread, it'll kind of keep going and keep executing.
There's that window of when the check happens and when the increase happens, basically.
Yeah, since I know Security Hook, since I know you're on the Discord, you can definitely hit me up there if you want me to explain that a little bit better. I can give you a couple resources about that. But essentially the idea is you need to lock the value or you need to double check the value while it's being locked. You need to prevent basically multiple threads from being able to do or modify that value while you're using it.
You need to guarantee exclusive access, to the resource. So yeah, it's a low severity issue, but it's another one that's, kind of fun. And despite the low severity, you actually got a $500 payout. So, low severity, but still got quite a payout for it. So that's pretty cool. But yeah, just another, CTF platform bug. And I don't know if we'll be seeing one of those again for a while, so definitely
Who
wanted
knows?
to shout it out. Yeah, no, we never saw one before. Well, I hadn't seen one before the last episode, and now we're seeing one. The ones last
Back to
episode
back,
and this
yeah.
episode. Yeah, but that's probably not going to happen again. So, just wanted to do a quick shout out for that. That being said, we'll get into some research. Our first research topic focuses on JavaScript and cross-site scripting vulnerabilities, and focuses the fact specifically that a lot of websites and applications will try to block parenthesis as one of their character set restrictions. So even if you get that cross-site scripting, if you have to call functions and stuff like that, which most often you want to do, if you can't use parenthesis, you're not going to be able to call functions. And essentially, the article talks about a cool trick using the fact that objects can have string representations returned by their constructors. And as the title suggests, there's one called DOMMatrix, which returns a string containing a function called a matrix with a set of parameters. So it's going to have those parentheses for you to use. And it's basically talking about how you can abuse that to call functions, even if you can't use parentheses directly in an XSS. So by setting matrix to whatever function you want to call, you can basically get a function call with parentheses.
Yeah, so you are limited a little bit. So you have your DOM matrix, so you do need to be able to kind of create the new item, or create the new object, sorry. And then it has within the matrix, like A, B, C, D, E, F as fields that you can modify. So if you set those just to your character numbers instead of actually setting the character itself, then your toString will end up grabbing we'll end up printing the actual characters out effectively. So you can chain that with multiple DOM matrices to create JavaScript URL. So you can do like your location equals, or href window location, sorry, to the JavaScript URL effectively that's built up using the DOM matrix. So I don't know if this is necessarily a new trick. I've never seen it before, so I thought it was interesting to point it out. Because I've definitely run into that scenario where, you can't use braces. So I've in the past used like on air to get around that. But this is just another trick that you can try if that won't work for whatever reason.
I found this article really cool. It's pretty short, like it's very accessible to get through, even if you're not really familiar with XSS. I think XSS is a fairly easy issue to understand as well. But like usually when you're talking about XSS, I find it kind of boring. But I think this like trick of getting around it, I thought was like really neat, just because it's kind of bringing that idea of building up primitives to do more useful things into web, which you don't always see. So yeah, I thought this was like a really cool, like short but sweet research post, basically.
Yeah, and I will mention that they do also have a lab here. That I believe is cool. So since it's mentioned right here in the document or in the research,
probably allows you to play around with it.
Oh, okay. So I haven't actually checked it out, so perhaps it's not the same issue, but it does say so. You want to experiment with these techniques, check out the lab. So I'm going to assume that this Portswigger lab, or sorry, the Web Academy lab, is dealing with the same issue. It might not be. I haven't verified that, but it's at least playing around with this type of issue.
That being said, I can't remember. Are the Portswigger labs free?
Yeah. Yeah, these are free. Like, I can go... Okay, you do have to log in. I forgot about that, and then you can start up the lab, but otherwise, yeah, it is free to access. That's why I figured I'd bring it up here.
Yeah, I just wanted to double check that, just because, I don't want to like recommend a lab or anything for people to check out, and then it's paid, and like not say that up front.
Yeah, no, fair point. And I actually for a while thought the Web Security Academy was free. I had somebody else kind of correct me on that. It's open. It's actually, this is one of the things that was in our recommendation for things to do while quarantined is the Web Security Academy. There is a lot of good stuff, and they keep this updated, which is one thing I like, because part of this was Web Application Hackers Handbook. Good book, but definitely showing its age by this point. So they introduced this as a way to kind of have a bit more of an updated resource for people to use.
Yeah. So, it looks pretty cool. We will jump into our last topic of the day, though, our last research topic.
And I really like this one.
Yeah. So that focuses on securing jump instructions against code reuse attacks. So what they're talking about here is basically the ability to hijack function pointers or something like that, for example, and an attacker can use that to chain gadgets together from the binary to get arbitrary code execution. So ROP, return-oriented programming, or jump-oriented programming, JOP.
Or call-oriented. Got to get
Yeah,
all the letters in there.
There's a bunch of different ones, yeah.
But yeah, it's code reuse attacks in general that's trying to protect against. It doesn't actually, so it does require that you have shadow stack array, which is where ROP's kind of being taken care of. This is more on the indirect jumps that they're kind of focusing on. Or I guess forward instead of backward branch, but...
Yeah. So they kind of talk about what makes their solution different from the classic CFI we've seen before, you know, the control flow integrity, that is. And they're proposing a system called Hurdle. And what makes it different from classic CFI is they're trying to use SMT constraint solving to try to ensure indirect control flow transfers can't execute gadget chains.
Yeah, so maybe jump in a little bit with the gist of what they're doing. I pulled out an image from their slides. There's nothing quite as good in the actual document, but their slides here had a really good example of kind of what they're trying to do is track branch history. So every time you branch, it's basically they've got this hurdle alphabet, they're calling it, where they take like, you know, is this a direct branch? If it's not taken, so if you take like the else of it, or if you take the true part of it, if it's unconditional, if it's called, like they basically have a letter to represent all of those. And then they're going to track that in I believe I want to say it's 7 bytes wide register history tracker. I don't think that's all stored in just the one. Actually, I guess that would fit in the 164-bit register. Yep. Yeah, it is the one register. But essentially, if you see the image on screen, I apologize for those of you just listening. You'll notice that they have the letters kind of indicated there, and you can kind of follow through a path. So starting at the top with the letter C, it's a call that's always taken that takes you there. Then you can kind of see how the branches go. Like if you go left and left, it's N, N, U. If you take third left there, and then C. So what happens is they'll try and figure out for the application basically all of the possible patterns that can get you to any of these kind of endpoints. It looks like they only check when you have kind of the direct calls. Any sort of, well, sorry, not direct calls, indirect calls actually, is where they actually check the gate pattern is what they're calling it. So that kind of combination of letters. So CNN, UC, they track 8 in the history, but basically when they get there, they also just check, hey, is this a valid path? Is there some way they could have actually reached this? So that's where Spectre mentioned the SMT solving. What they'll do is you'll run this application completely uninstrumented, and it's just looking, or it's just tracking all of the different positive ways that it can reach it. So you need to have a good test suite. You'll run it through there and all the possibilities, it just keeps track of it. SMT solver figures out basically your minimum set of, or all your possibilities at each gate that can check, and then it instruments the binary with those checks. Look at the branch history register, the extended branch history register, to see if that's actually matching. And they do a little bit of extra work in there. They talk about having synthetic branches. So one issue, if you're kind of thinking about this and thinking about how you might break this, might be, well, what happens if I want to jump, if 2 places I want to jump between actually can have the same kind of previous branches, can have that same pattern beforehand. What they do is they introduce synthetic branches. So again, the SMT solver can kind of find that, and it can know like, hey, these branches are actually compatible. You can jump from here to here, and you shouldn't be able to. And it'll just inject essentially fake branches that'll cause it to mismatch.
Yeah. Now, in order to enforce that, it uses its own like instruction that they came up with, which does need support at the hardware level. They propose like an instruction set architecture extension for x86 to be able to enforce this when they instrument the binary. Yeah, and I believe which is kind of like a high, condition.
I believe the extended branch history register is also something that they're at, like, is needed at the architectural level. Because the branch history register normally would be too small for it.
Yeah. Did you have anything else on like the specifics of it, or because I just wanted to talk about some things I found that were like an issue,
Some of the issues.
in my opinion.
I guess I will also mention that CET is necessary, Intel CET, control flow enforcement technology, which isn't super common yet. I'm not even sure if it's quite out. Do you know? Is there anything supporting it yet?
I don't think so.
Okay, I feel like there might be something. Maybe Xeons. I don't know. Either way, it does also rely on that. So it relies on some other technology before you kind of get to this being able to use their system here. And also, I will mention before we forget, there is a YouTube video, and it's a really good overview of it. I'm just pulling it up here.
Oh, come on! You never linked this to me.
Actually, I did, but we can talk about that after.
Oh, okay.
It's in the description. It's in the comments.
Oh, okay.
But anyway, so there's a YouTube video. It's a really good overview. It does leave out some of the things like this synthetic branching, but if you want a really good overview, it's really quick and easy. He goes through it. Yeah, it was actually a pretty good presentation for what it's covering.
Yeah.
Like not super entertaining, but good in terms of what it covered.
So when you were talking about the patterns, the question that arises there is what happens if it fails to find a set of acceptable patterns. And they kind of mentioned that, but what I found really weird was they don't really seem to address that point. They say in practice it scales to large programs like GCC, I think they mentioned, but they don't seem to directly address what happens if they fail to find a set of acceptable patterns. I'm guessing in those cases they just don't place that instrumentation there, and those are holes that can be used by an attacker. So it is still harder to hit, but it does seem like, in those cases where it can't find acceptable patterns, those are kind of holes that are left open that are not enforced. Really, I'm guessing
there are some issues with this, and there are things that maybe will be dealt with in the future. I don't think they're impossible to solve, but so one gadgets would be one case. Effectively, if you're able to pull off something with just one gadget, or if you're able to kind of separate your calls out, return to a proper state after your first gadget and then kind of keep going like that, that would be a way that you can kind of chain things. Because basically your first time through, you're going to have pretty good control flow. And you're going to be, because your first jump is generally going to be at an expected location. Right, and that's also one of the assumptions that they make. So they don't do much if you only need one gadget. The other thing is libraries. All of your libraries need to opt in, need to compile with this also, which is going to be
which they're not going to.
Yeah, I mean, if it got adopted pretty well, they might. I mean, but consider how long it took for ASLR to even get things opting into it.
Yeah, that's what I mean. Is I think even with GCC, for example, position independent executables is not a default flag. You have to compile that explicitly. So it could be one of those things where even if this is used, the libraries, like you were saying, might not be protected, and people might just forget to opt into that.
Yeah, and I guess one of the other issues is just those patterns, the gate patterns that we mentioned, they're based on the training data that came in, which means there's the chance that if your training data does not cover all your functionality, it's not going to know. It's going to think those are all just fake paths that can't be hit. And it'll crash or it'll reject it at that point, which could be good, could be bad. On the good side, I mean, that means generally those code paths that you're not thinking of, those code paths that you forget about and don't test, just aren't going to be covered. So it is kind of a good thing. But I think that is something that's also going to lead to a reduced adoption. Just because, I mean, if you sit there and you're building your application, yes, your tests, you want to have really good code coverage, but it's not always worth the effort to go from 80% to 95% or something. Usually you've kind of got a good enough test cases, so in that 20%, either you need to put in the effort to get the test cases for that, or you need to accept that users won't be able to use that functionality, which is generally going to be a no-go.
Yeah, not optimal at all. for like actual users of your application. You don't want to
unless you have really good
generally.
Unless you have really good test cases, it isn't useful. That said, like if this were used in general, like it's pretty strong. Obviously, we've mentioned a few of the issues. Like there are cases where it could be exploited, but would prevent a number of cases too.
So here's where some of my reservations come up. Is when you're talking about a system like this, the big question is what's the overhead?
Of course.
They have like an average of I think they said like 1.02%, which isn't really that high. But if you go to page 12, they have a graph that shows their measurements on various applications. And they do have some real-world applications there, like GCC, bzip2, various crypto, like Blowfish and stuff like that. But here's my problem with their target selection. These aren't really targets that are common for exploitation. Not many people are going to be exploiting GCC or something like that. It's just not a very good vector. When you're talking about things that are commonly exploited, you start talking about things like browsers, editors, kernels, larger apps like that, and there's none of that here. And I feel like that might be intentional because when you're talking about apps like browsers, stuff like that, there's a lot more indirection, and I think the overhead will actually be a lot higher in those cases. So, and there's like, I don't think any of those examples there are C++ either, which would be interesting to see. I could be wrong.
True, actually, because like for vtables and everything else in
exactly.
C++, that's a good point.
There's so much indirection there, and I think the overhead is going to be super high in those cases, or at least a lot higher than what they're reporting. So I think that there's a bit of an issue that I take with their testing and their basically their data set that they use. I think they should have tested more applications that would actually make use of this technology, whereas a lot of these, applications, people aren't really going to be exploiting those, except for in like rare cases. So that's.
I don't know. I want to target shrink search now.
just to prove me wrong. Yeah, I mean, yeah. So that was kind of one of my thoughts. The other thing is it requires so much work to even adapt it. The fact that it needs hardware support, like ISA extensions, that's a big requirement. And then you also have to make sure that libraries opt into it. You were saying that I think, what was that? Intel CET is also needed. So it's like there's so many technologies needed to even use this. I think it's cool. It's like something cool that they explored. I just don't see it really being adopted. Like, I just don't think it's really going to
neither do I.
In real world. Yeah. So, it's definitely, I'm not saying it's not worth the read. I think there's some cool stuff in there.
Oh, yeah. So I like the idea. I mean, that's why I said up front, like, I like the paper. I like the idea. I don't think it's going to be adopted. I agree with you on that, but that doesn't mean I don't like it.
Oh no, for sure. I'm not trying to say you should hate it or something like that. I'm just saying, like, I do take issue with some of their points on like real world applicability. It seems like they make it seem more real world accessible than it actually is. You know what I mean? It seems like they're trying to oversell it a little bit in that regard. And that was just something that I wanted to kind of point out. But yeah, overall, I think it's cool. It's just you got to keep that reservation in mind, really.
Yeah, I mean, when it comes to security, like on the performance side, I can't see the performance being as low as they claim. Like you were mentioning, when you have more indirection, when you have those more complicated programs, I really can't see it holding the level of performance that they see with these test cases.
I really wish they included some C++ examples in there if they haven't already, just because like the vtables and stuff like that, I think is where you're going to see the big hit. That's where you're going to see the real like overhead, because C++ is used quite a bit in a lot of applications, like game engines and browsers and stuff like that. So it should have been measured. If I could be wrong, I will say I don't recognize all the applications in the list they tested, so maybe there is a C++ app or two in there, but it didn't seem like it, because the ones I did recognize are all just C. So that just might be worth keeping in mind.
Yeah, I can't speak for what any of them are. That said, at the very least, I mean, seeing the performance on a larger application, just plain and simple, leaving it at that. Not necessarily C++, just larger real-world application that you might actually want to see this deployed against.
Yeah. That being said, though, that pretty much summarizes all the topics that we had. I don't know if we have any last minute additions, just because we
I
did the
don't.
shoutouts up front. So yeah, I don't think I have anything else either. I will say, just to plug it again, you can check out the video we did last week for the activities you can do while in self isolation, or just you can check out our text post too, because that has some laid out thoughts that aren't in the video, so you can check out both. But other than that, we will be continuing the podcast through this stuff. We do it remotely, so luckily this pandemic stuff doesn't really affect our podcast. So we're going to continue doing that on Mondays at 3 p.m. Eastern, 12 p.m. Pacific. But yeah, so we will see you guys next Monday with episode 35.